Good morning, everybody, and welcome to the Gulf of Mexico Forum webinar for October. Happy fiscal year 2025. I can't believe we're already there, but here we are. And I also wanted to mention that today's webinar is brought to you by the NOAA Gulf of Mexico Regional Collaboration Team, which is part of NOAA's Regional Collaboration Network. We have an awesome lineup of speakers today, but I want to go through some quick webinar etiquette first. First off, if you're joining the audio via the webinar provided phone line, there is something called an audio pin in your GoToWebinar dropdown. It is on this little audio dropdown thing with an access code and an audio pin right there. If you're not seeing it, you've already entered it. And if you're joining via the webinar computer interface, so if you're listening through your computer speakers, you don't need to worry about it. It's already good. Couple of little housekeeping items. We are recording today's presentation, so please do not share any personal or business identifiable information. Participants will be joined to audio in mute status. And except for presenters, please leave your webcam off. It just helps people to focus more on who's speaking. Because we do have 4 different topics and 4 different presenters today, we're keeping the questions to written only. So my colleague, also Shay Delino, with the national part of the Regional Collaboration Network, is my co-organizer. She and I will both be monitoring the question box in order to share questions during the Q&A after the presentation. We're going to have a quick question break after each presenter, and then at the end, if we have time, hopefully we will have time for more general open questions. Also, please know that if you write in a question, we will have a record of your question, and we'll be able to get that to the presenters as well if we're not able to get it to you. You might see a questions drop down for opening that box in your webinar interface, or you might see this little text box looking thing with a question mark in it, which should also open up your question tab to be able to enter a question. All right. Today, I'm really excited because we have a really broad array of data or information resource spotlights. I did want to mention real quick that this is a variety of resources. Not all of them are data sources. Some of them are viewers, some of them are have more on the data side, but it's a really great mix of information. First up will be Paul Fanelli with the Coastal Inundation Dashboard. And while I mention and everybody else, Paul, I am going to turn the viewer over to you. Just a second. Let me pull you up and make presenter. Okay. Our other presentations include Chris Ridener and Don Rinker with the National Weather Service GIS viewer. Adam Pollack with the Southeast Fisheries Science Center will be talking about Seafish, which is the Southeast Abundance of Fish and Shrimp Data Visualizer. And Megan Howson and Jerad King with the Gulf Coastal Ocean Observing System will talk about CETACEAN, which is a really long acronym. It is compilation of environmental threat and animal data for cetacean population health analysis platforms. So with that, welcome everyone. And Paul, it's all yours. Thank you.
Great. Good morning, everybody. Thanks for joining. Very happy to give an overview of our Coastal Inundation Dashboard web mapping tool. My name is Paul Fanelli. I'm a senior oceanographer within the Coastal Hazards Branch at COOPS, which is under the National Ocean Service. So again, I'm going to talk to you today about this great tool that we have for monitoring coastal flooding, both now and better understanding flood frequency, past and future. So just a very brief background on COOPS. We're the tides and currents people. We maintain a network of oceanographic and meteorological sensors along the nation's coast, including the Pacific Islands, the Caribbean, of course, the Gulf of Mexico. We maintain these sensors, and we also push out the data that are used for a variety of purposes, like navigation and coastal hazard monitoring. The backbone of this is our National Water Level Observation Network, which is a network of over 200 real-time stations. These stations are hardened. They can withstand pretty significant weather, not necessarily everything you can throw at it, but almost everything. Helene actually did not impact significantly any of our stations that were in the immediate vicinity of where the storm made landfall. And that's a testament to how durable our stations are. But this data, a lot of these stations have been around for decades. Some of these stations have been around over a century. San Francisco has been around for 150 years. That allows us to not just use the data for real-time coastal, water level monitoring, but also be able to use the data for things like tracking sea level change. One of the core uses of the data is for mitigating coastal hazards, and we do that through products like the Coastal Inundation Dashboard for disseminating the water level observations. But also we have a tsunami mission where we have our stations, which are normally 6-minute data. We collect 1-minute data to help support tsunami monitoring along the coast. That's heavily used by the National Weather Service tsunami warning centers. And again, because a lot of our stations are long-term, we can calculate those relative sea level trends at each of our long-term stations as well. Key products, again, Coastal Inundation Dashboard. We have high tide flooding outlooks, which now project potential flood days just from high tide flooding up to a year out. And we also have annual high tide flood outlook, which projects how many flood days we might have next year. And we actually go out decadally based on expected sea level rise, how many flood days we might have in the decades to come. Again, we have this great wealth of historical water level data, which allows us to track the observed sea level trend through the station's history. But the focus of this talk is going to be Coastal Inundation Dashboard. It's a web-based product. We have, again, it's a way to view our observational data through the lens of coastal flooding. Water level data is displayed relative to high tide or mean high or high water tidal datum, as opposed to low tide. Low tide is typically used as a reference level for navigation, whereas high tide is typically used as a reference level for understanding coastal monitoring. So how high is water level getting above normal high tide? It's a better way to communicate how high water levels are along the coast. The product pulls in a bunch of layers from outside of co-ops, and I'll get into that in a little bit. But this is just meant to be the portal to look at water level information if you're interested in coastal flooding along the tidal coast. An integral part of this is understanding what levels you might see flooding. So what those coastal flood, minor, moderate, major flood thresholds are. And a lot of these are determined by the local weather forecast offices who have kind of that on the ground, boots on the ground understanding. They work with the emergency managers. They know when roads are getting closed, when water starts to infiltrate into buildings. So a lot of our stations, they've established minor, moderate, and major coastal flooding thresholds. Minor is your typical, very minor street level flooding, parking lot flooding. Moderate, you might start to get some impacts to buildings. And in major, of course, you have a higher probability of impacts to structures and infrastructure, as well as potential injuries or loss of life if people put themselves in harm's way. And it's very specific to each location, which is why, again, we rely on the weather forecast offices who have that local perspective. So we pull in a lot of map layers. As I mentioned, we have our observational data. So between our NLON network and our real-time partnership stations, we have about 300 real-time stations in the product. On top of that, we have some additional partner stations we pull in, which I'll talk about in a second. We do pull in some layers from other parts of the Weather Service, like the National Hurricane Center Tropical Cyclone Information, coastal flood watches, warnings, and advisories, which are issued by those local weather forecast offices. We have coastal flood impact graphics and webcams, which I'll talk a little bit. That's more along the lines of relating what's happening at the water level station to what you're actually seeing on the ground. We pull in cloud cover from NowCoast, from NOAA's NowCoast resource, and we pull in the sea level rise viewer information and minor coastal flood inundation from NOAA's Office of Coastal Management. And that actually shows you on the ground in the lower left image what areas you might start to see flooding at a specific height above normal high tide. So in this case, I think it's 5 feet above high tide. So that could be 5 feet of storm surge, or they could be 5 feet of sea level rise. These are the areas, those low-lying areas that might be impacted. And a lot of these layers, actually things like the coastal flood watches and warnings and the Hurricane Center stuff, we pull in from the NWS map services, which you'll hear about a little later in this hour. So for our stations, I mentioned, we have 200 plus long-term NLON stations. We also have a number of that are part of our physical oceanographic real-time system and our Texas Coastal Ocean Observing Network. These are partnership gauges where we pull the data in and we disseminate them. We verify the water level data. So in all, we have about 300 water level stations that we disseminate and quality control in real time through Coastal Inundation Dashboard, as well as other products on the Tides and Currents website. Within each of these, you can look at data just by clicking on the station marker on the map. You can see up top that some of those stations are blinking. If you looked at the product today, you would see probably those same stations blinking because there's a lot of minor flooding happening in the Mid-Atlantic. And if you click on Inundation History page, which is down in the lower left-hand corner of the pop-up, that'll bring you to a page that goes kind of delves a little bit deeper into the station history. Some of those features I'll talk about very briefly in a slide or two, but it gives you an idea of, through the map, you can see like the latest water level data, but then you can look at the station's history and delve deeper if that is what you're interested in. In addition to the 300 stations that we quality control real time, we also have another 300 stations about along the coast that we pull in from the National Water Prediction Service, which is run by the Weather Service. These are just coastal observations that fall in between our stations. We just show them for to be able to fill in some of those gaps. So again, we point back to the National Water Prediction Service, but it's just allowing users to not have to go to two separate products if they're interested in coastal water levels. There's a lot more than 300 stations in NWIPS. There's a lot of inland stations, but we pulled out 300 of them that are along the tidal coast that kind of supplement our network. We're also working with the Integrated Ocean Observing System, or IOS, which is another program office within the National Ocean Service, to pull in additional water level observations that are coordinated by their regional networks. That is very new, so we only have a very small number of stations, but again, this is looking to fill those gaps. It costs us a lot of money to maintain our water level network, so we're trying to leverage other groups who are also collecting coastal water level observations and add those to the product to be able to supplement our network to be able to show those real-time coastal water levels for storm surge, coastal flooding monitoring. I mentioned coastal webcams is one of the layers that we've recently added. This is also run through one of the IU's regional associations, in this case, SICORA, the Southeast Regional Association. They run a program called the Webcam Coastal Ocean Observing System, or WebCOOS, and they have 17 webcams that we have integrated into the product. We point to them. They house the images, they house the real-time data feed, but this allows you then to, if you're looking along the coast and you see water levels are elevated, you can actually click on one of these webcams and see how it's manifesting itself along the ground. And this is a really good example of it. You can see that as water levels rise, this is our Charleston, South Carolina tide gauge, and our the webcam is very close to that. So as water levels start to rise, you can see it starts to get, especially on that bridge, if you focus on that bridge, and the next high tide, it's really where you're going to see it. Water levels really got high and started to infiltrate over that seawall. These are really great tools for understanding on-the-ground impacts. And the hope is that WebCOOS, I believe there's funding for them to build out their network. So as more coastal webcams are added, we will integrate them into the dashboard to be able to, have this be another source to understand on-the-ground impacts that are associated with elevated water levels along the coast. On the map, there are a couple of ways to look at multiple data, multiple stations at a time. The latest data option will give you this great little table here that's just a quick and dirty, what's the latest observation. This also might be a little difficult to see. There's a column for 72-hour maximum water level. So it's a great tool to be able to see what the peak water level was from the most recent high tide flood event, or coastal or storm surge event or hurricane or whatever caused the elevated water levels. We also have a multi-station view, which will generate kind of a page where you can look at.
Hey, Paul?
Yes.
You have about 1 minute left.
Great. Where you can look at water levels from multiple stations at a single time. And you also have the ability to share a map. You can generate a custom URL with those layers, the map zoomed into where you want, with those layers toggled on. You can share that with other people if you're only interested in a specific area. Within each station, we compute historical flood days. This is essentially how many days water levels eclipse the minor flood threshold. We break it down annually by season, and actually you can drill down to individual flood days. Typically, this is based on flooding that's about 1.5 to 2 feet above high tide. We also track top 10 water levels for each station. So we just did a lot of updating for Hurricane Helene, which broke records at 6 stations in the Eastern Gulf. So this is another resource to see what the current storm is doing relative to that historic content. And speaking of Hurricane Helene, whenever we have a tropical cyclone that impacts the coast, we will push out a storm dashboard, which essentially is like that share map feature, but it'll have a storm specific URL. The map by default will be zoomed into the region being impacted by the storm with those relevant layers turned on. We'll update this 3 times a day. Again, we're pulling in the latest track information and the latest coastal watch and warning information from Weather Service map services, but this is a great tool. We'll have a banner on our front page that'll show that we're monitoring, and this is typically something that will be pushed out on NOS and NOAA social media. And that's what I've got.
That's awesome. Thank you so much, Paul. There's so much information in there about flooding. And it's just from a personal view, it's really great to hear that all of your stations stayed up during Helene. I know that, that's always a risk. So it's good that the station stayed up.
Our station at Cedar Key reached over 9 feet above normal high tide, which broke the record set last year during Idalia by over 2 feet.
My goodness.
Yeah, I mean, you saw, I'm sure a lot of folks have seen damage photos. It's just, it's heartbreaking.
Yeah, heartbreaking and beyond words. It's just really thinking about everybody impacted by Helene. Thinking about the inundation dashboard, I'd imagine it's really good for people to think about what this all means with regard to where they are, right? So as in, like, if they're seeing what a certain water level height at their nearest station, what does that mean for coastal flooding, and when does it begin to become impactful in their own area, right?
Right. So I mentioned, the National Weather Service forecast offices, they have, minor, moderate, major flood thresholds for most of our network, and actually most of the other stations right along the coast as well. But what they denote as flooding might not necessarily be, what a particular someone who owns a business or a house right along the coast, they might have a different height, based on prior experience as to what height water levels need to reach before they start to see impacts. So one of the great things, I talked a little bit about the historical flood days. Part of that, part of the application allows you to actually customize the flood threshold. And you can kind of recompute those historic flood days on your own threshold. So maybe the National Weather Service flood threshold is 1.5 feet above mean high water, which again is normal high tide. But you start to see impacts at 1 feet above mean high water. So you can recompute those historic days, see how many instances in the past that happened, to get a better feel for the increase in flood frequency, which again is what we're seeing in a lot of locations with sea level rise. That flood frequency is just going to continue to increase.
Got it. Thank you, Paul. It's also really exciting to hear about the IU's webcam data coming in. You mentioned that WebCoos is hopefully planning to expand. Do you have any ideas where they're going to try and go next?
Well, they're definitely going to be expanding outside. So most of the cameras are in the Southeast region, but I believe there's funding available for each individual IU's region, of which I lost track, but there's definitely a Gulf one. There's one in the Gulf. There's one actually in the Corpus Christi area in the Gulf. But over the next few years, I look to see this impacting. I think I heard, and don't quote me on this number, I heard 6 per region per year. But
wow.
as webcams are brought online along the coast, again, we'll add dots on the map for those so people can look at those on WebCoos. Of course, there is a WebCoos portal, which is linked in my presentation, which I believe will be shared with everybody after this. But this is something that's really exciting. And within co-ops, again, we maintain this large network of stations. They've actually, we've actually supported them in the installation of coastal webcams near a couple of our stations. Charleston is the one that I showed was one of them. Beaufort, South Carolina, or Beaufort, North Carolina is another one. So I look at, there are opportunities for us co-ops to help support them as well, installing some of these webcams very close to our stations, again, to be able to track those on the ground impacts, see when you're actually starting to see flooding.
Wonderful. Thank you again, Paul. And hopefully we'll have a little time for more questions at the end. And now I will turn it over to Chris Ridener to share about the Weather Service GIS viewer.
Hey y'all, can everybody hear me?
Yes, we can hear you, and you're up on webcam, and we're seeing your web browser with the, looks like the opening page. There we go.
Great. Well, thanks y'all. My name is Chris Ridener. I am a visiting scientist from UCAR-NCAR here in Boulder, working with the Office of Dissemination, and Donald Rinker is here on the call with me, also from Office of Dissemination. And I am going to talk about the National Weather GIS Viewer. I do have a slideshow, but the viewer is really interactive, and I think it's easier and better for me to go through and do a demo of it. With the live viewer up, y'all can follow along if you want to. I'm putting the address in the chat. It's viewer.weather.noaa.gov, and you can drive along and play along with it if you want. When you go to basically the viewer, I think of there's a lot of viewers in the Weather Service and everywhere else, but I think of the viewer, the NWS GIS viewer, as kind of a clearinghouse for all the federally produced weather data. And one of the differences in us is the amount of data that we have in our viewer. If you go here to the layers, you can see we probably got a couple thousand layers here of data sets. And those get down into some of the stuff like Paul was just talking about. We've got some of the flood inundation maps here. Most of these are coming from National Weather Service, Cloud GIS dissemination. So the viewer actually isn't a data source per se, but we like to be able to point any data that we're using to the data source. So you can see here, we've got these default layers turned on the general page. The viewer has 10 program sites. 4 of them are operational now. We're waiting to take the experimental tags off the other 6. We're working on those. The fire site should be next. But if you go here to the general page, this is basically the default page of the viewer. And you can get to the other pages from change sites or up top here. When you're at the layer, you can click on here. But just an example of our data sources. So one of the default layers we use on the general site is the watches, warnings, and advisories, the weather alert hazards coming from the Weather Service. You can see here, I've got this layer turned on right here. And the way we like to point to the data sources is through the metadata. Right click, this shows the layer properties, a lot of power in the layers here from being able to look at the data and the metadata. So right here is a metadata link. If you go here, these metadata links will have all of the graphical web pages and other data sources if a user wants to download or to put in their own GIS or their own application. But if you click here, is to show you this is going exactly to weather.gov. And so if you get, these are just the same WAWA shape files that are produced from all the WFOs throughout the country, and those get processed and disseminated through Cloud GIS here. And this is where NWS disseminates all the weather products that they have, the weather data products. You come here and you can see right here is the watches, warnings, and advisories data source. If you go to the REST service directory here, GIS practitioners can go in here, find what they want, put in their own GIS, or display it however they would like to. So that's just a little note about the data in here, in the viewer here. I'm going to go through just a couple little other nuances that our viewer has, just that users can see really without having to dig down or dive down or get lost or anything like that in the viewer. The WAWA layer is one of our most featured, and we built some of the most tools around it because we want to be able to display this data as easily as we can. So one of the features that the viewer has that I don't think any other viewers has, and it's not on government or weather.gov, is a pop-up function here to be able to see, to just hover the mouse over the alert, see what it is. A new feature that we're going to have coming in this next release of the viewer is going to show the start and the end notice of all these alerts of any active WAWA alert. And so you can easily just scroll around. That's another power of the viewer, is the extent. We have most of our data covers OCONUS. And so with this WAWA feature, or hover over feature, you can easily see what's in the data. Another cool and unique tool that our viewer has is this default here. If you point click on the map right now, it actually goes to our default ID tool, which is up here also. But this one is really cool because you can go right to whatever hazard it's on, and it will pull up the text details, and you can see exactly what the text details of the alerts are. This point click also brings a drop down here. So this drop down will take you to the get point weather forecast, which is this tool right here also. But here in this pane, we have several other interactive features that we can use to look at these alerts. So you can obviously see the 10-day forecast. You can go to the end, view the NWS full weather forecast for it, take you to this forecast page. Back here on these tabs here, we have a forecast summary, which will bring up the weather summary for the next 7 days. The tabular forecast, which I'm pretty sure a lot of meteorologists are interested in, is here for the next 7 days as well. We have a graphical forecast here, displays the graphical forecast, temperature, dew point, relative humidity, wind speed, probability, precipitation, thunder, and precipitation, sky cover, visibility. And then the last tab here goes back to whatever active alert is displayed. And you can click on this here to get some more details about it, and then get back to the text bulletin again here. So this is, I think, pretty unique tools in the NWS GIS viewer. I do not think that many other viewers have implemented these tools. And then, so another thing is, the last part of the dropdown will take you to the identify tool, which is basically just the attribute table. So if you want to look at the attribute table here in the map, click over here to the tab, and it'll show all the weather alerts here in a table, attribute table format. Another cool feature I'll show you all real quick, since the audience is ocean site, is the marine page. We have a different default layer here. This page has default layers of the beach hazards layer that was just produced and disseminated by the NWS. So here we can see beach hazards. If we use the drop down here, it will go to this beach hazards. It'll bring populate another field for the drop down menu, which will bring up the beach hazards tool. There's a rip current statement here. But if there's actually beach warnings, which I will find. Well, hold on, sorry y'all. This is still kind of new, but I'm gonna jump off this right now because I don't know if it's gonna pull up what I want. But anyway, so the next tool I want to show y'all, and the we are working on a beach hazards dashboard too. We do have dashboard functionality in the viewer. Right now, we only have one built for the fire site, which I will just show you all real quick. If you go to the fire site, the way to get to the viewer dashboards is through this other tab here, and then the dashboards. So like I said, we're in the process of building a dashboard for beach hazards, which will go through and display information on beach hazards that are going on. Our dashboards are scaled to the extent. So if we pick just whatever extent on the map, it's just going to show the features and interactive. The cards here are just going to show what is in the map scale. So this elk fire here is a big one that's happening up in Wyoming right now. It blew up. I think it's been doubling like every day, but it was like 20,000 acres yesterday. So this is just an example of our dashboards here in the viewer. And like I said, we are in the process of building a beach hazards one, which will be coming out in. Yes.
Want to let you know you got about a minute left.
Okay, just gonna show you all one more thing, is the print function here in the viewer. So this is good because you can get, you can mess around with the print functionality. If you come in here to this top tool here is the print tool. It will bring up all the layers that you have turned on in the map extent. You can mess around with this legend. You can like put it wherever you want. You can save these as PDFs for sending as emails or PNGs for putting in a slideshow. But it also, you can zoom in and out of the map if you need to readjust what you want to print out. So the print functionality is something that's really handy for decision makers and emergency responders. But I think that's it. And so I think take any questions that y'all have.
Great, thank you so much, Chris. That's a really powerful viewer. I appreciate you and Don both for sharing this today. First question, what should a user do if a viewer layer or a viewer isn't working?
First thing, just wait a couple seconds. We have so many networks going through the viewer and everybody's on a different network. And so there could be network outages in different parts of the country. That's another thing, just remember the scale of it and wherever the data is coming from. Sometimes there could be a data outage and the source might not even know about it. And so if it's a specific layer that is not drawing, if all the rest of the layers are drawing, then you can go to the source, check it out, look there in ArcGIS online from the service directory, see if it's drawing there, and if it's not drawing or working there, try and contact the source.
Got it. Thank you, Chris.
So like last week, we had some pretty big outages in the services from Helene in the NHC products, the tropical products coming from into CloudGIS, and then dissemination was hard. We were getting outages, pushing them into the viewer, and then we also had so much traffic on the viewer itself that it kind of busted that. So it was just like a lot. There's a confluence. There's so many things and so many firewalls and stuff like that that come from the services up through the viewer, and then people could have network problems on their end. So there could be a whole myriad of problems that could be going on that would cause a viewer to be out or a layer to not work.
I can imagine that can be challenging, especially when you have such a big event as Helene and everybody's trying to get the information at once. One more question, and we have a number of them coming in actually. Thank you all. Andrew Fritz asks, is there a plan to implement additional marine observations such as the buoy data that's generated by the National Buoy Data Center?
The buoy data has been weird for us to get. Don?
Yeah, so the way things generally work is that we need to create a service out of them, and then the viewer can consume them. So it's just a matter of us getting some time and resources to add everybody's favorite data sets to our services and move that way.
All right, thank you.
I also want to note that we dropped some links and email addresses that you can reach out to us. They should be in the chat.
Great, thank you, Don. I will double check and make sure that that's reaching everybody. Great. Chris and Don, thank you so much. Oh, wow. What are you showing right now, Chris? Just real quick. And I think you might be on mute.
Sorry. This is on the marine site. I just turned on the layer with the tropical cyclone heat potential down here. We don't have a whole lot of ocean observations in it in the viewer right now. We do have some raster data with surface currents. ocean temperature, and temperature anomalies.
Wow. That's really, just from a completely non-technical standpoint, I know it is very useful information. And that is also just really fascinating to see too. Thank you for sharing that.
Sure.
All right. Really appreciate it, Chris and Don. And with that, we will move to Adam Pollack with Seafish. Adam, I'm going to turn the presentation over to you now. All right, and we're seeing your presentation view now. It looks good.
Perfect. Well, thank you everyone for being here. My name is Adam Pollack. I am a fish biologist in the Southeast Fisheries Science Center for NOAA Fisheries. And today I'm going to be talking to you about a new data visualization tool that we developed called Seafish. So before I get into the actual tool itself, I just wanted to give a little background. Within the Southeast Fisheries Science Center, one of our main missions is we conduct a number of fishery independent surveys every year. These surveys go out and sample everything from the smallest fish in the plankton up through shrimp and ground fish with nets. We have video surveys that are surveying the natural and artificial reefs. And then we have a longline survey that's targeting mainly sharks and then adult snappers and groupers. So from these surveys, we collect a lot of data. And the ultimate goal is a lot of this data ends up in stock assessments. And the stock assessments are used to ultimately help evaluate stock status of the different species throughout the region. So knowing that, we're going to get into what is Seafish. So Seafish stands for the Southeast Abundance of Fish and Data Visualizer. And what it does, it provides relative abundance trends for commercially and recreationally important species throughout both the Gulf of Mexico and the southeastern U.S. Atlantic Ocean. And on this page, you can see just a brief view of many of the different species that we have data for within this visualizer. So the question is, why did we develop Seafish? Well, ultimately, it's important to know the status of stocks for better management. Throughout the U.S., there's a lot of stocks that are either overfished or there's overfishing occurring. When that happens, managers have to put regulations in place to help build the stocks back up to a sustainable status. And through that, the issue is with stock assessments, there's multiple years between assessments for many species. And even a single stock assessment, from beginning to end can last anywhere from 1 to 3 years on average. So when the stock assessment's finished, it may be 1 or 2 years behind in the actual data that's feeding into it. So with this data visualizer, it's ultimately enabling managers to respond more quickly between assessments if there's any considerable changes in these abundance trends. So I've touched a little bit on this, who is Seafish for? Seafish was initially designed for fisheries managers and for the stock assessment scientists that put together the assessments. But overall, there's been a lot of interest from the general public in seeing these trends that we're seeing, because a lot of these people, commercial fishermen, recreational fishermen, they're on the water, a lot throughout the year, and they're usually the ones that bring questions to the fisheries managers first, saying, hey, we've been out fishing, we're seeing a decline in species X, can you help us with, can you kind of give us an idea of what's going on? So in the past, what they would have to do is the councils would go to the science center and say, can you please put together all the information that you have, for this species? What this allows them to do is now they have an online resource that they can just go to, and they can see all the latest data that's available for those species. So I'm going to give a demo of how Seafish work, but just in general, I kind of wanted to walk you through what you would see if you went to the Seafish site. So in the upper left, you have your navigation pane. This is just going to allow you to get through, the different groups of fish that you might find, the different species, and then what region you're looking for. Some people may be more interested in the South Atlantic, while other people may be interested in the Gulf of Mexico for certain species. And then even within those regions, sometimes assessments are broken up into subregions, so you have the option to look at all the different subregions. Here, this just gives you the species name and the region that you're looking at. Here is a link to the most recent assessment that is going to have the most recent data in it. This is a link to the species profile on the NOAA fisheries site if it's available. This just has general information about the species. This is the survey name that the data is coming from and the life stage sampled. And it's important to note here that most of these surveys are selective in the age of fish that they're collecting. You have a trawl survey, it may be collecting more juveniles. The video survey and the long line survey are collecting more adults. So it's important to know when you're looking at these, what portion of the population you're looking at the trends for. And then this is a link to a CETAR working paper, and it's basically a link to the methodology that was used to put together these abundance indices. If you're interested in seeing how they were put together, what variables might have been used in the model, you can click on this and get a full description. And then finally, this is the relative abundance index. This is really what the managers are looking at so they can see the trends in the stock over time. Now, I'm going to take you to the actual Seafish website. So this is the whole tool on the NOAA fisheries site. The first thing is right here to click more about Seafish to learn about it. And this goes on to kind of explain what I've explained to everyone here, just with a lot more information. It explains what you're going to see in it. It explains how to use Seafish. It goes into a little bit of the data sources that feed into it. And then it just talks about in general what a relative abundance index is in case, who's ever looking at it aren't familiar with the information. So here, we're back in the tool itself. We can start here on red snapper in the South Atlantic. And like I said, if you're interested, here's the link to the CETAR species profile. If you weren't interested in the South Atlantic, but the Gulf of Mexico, you just come to this drop down. And then here in the Gulf, the stock is split east and west. So you can go through and view either the subregion for the east or the west. You'll notice, depending on the species, there may be multiple indices. And you'll see here how these indices differ a little bit. And that's why it's important to know which portion of the population, excuse me, that you're looking at when you're looking at these indices. So just an example, if you were interested in, say, shrimp, you could click on the group for shrimp. You leave it at brown shrimp. If you were interested about the most recent CETAR, you can click on this. It takes you to the page, gives you a description of the project and all the information and data sources that go into it. This is a link to the, like I mentioned, to the species profile. This takes you to the NOAA fisheries site, might give you a little bit more about the species, and then just some general information, where it's found, what the status of the population is, what the fishing rate is, a little bit about the biology, and just some general information about it that people might be interested in. And then finally, if you're interested in the nuts and bolts of how these indices are put together, you can click on this working paper link, and this will take you to the actual working paper for that species. And this goes a lot more into depth about the survey and the methodology used, if you're interested to see just how those indices are put together. So we'll jump back to,
Hey, Adam,
yes.
you have a little under a minute left.
Okay, thank you.
Mhm.
And so with that, I want to thank everyone, especially a big thank you to the NOAA Fisheries Office of Science and Technology, especially Avi and Maddie Litwack. They are the ones that did a lot of the behind the scenes coding for this. And with that, I will take any questions.
Wonderful. Thank you, Adam. That's a great resource of information about fisheries in this part of the country. One question, how do the indices presented in Seafish relate to stock assessments?
Okay, so the indices that we're presenting here, they're part of the stock assessment, but they're one of many pieces that go into the assessment. For a full assessment to be run, you usually have, the indices from these surveys, and then you may have like life history data, you may have aging data, you have catches from the commercial and recreational fisheries. So this is a small piece, but it can also be a piece that can give managers kind of a heads up between the assessments of what's going on within the population.
Great, thank you, Adam. Yeah, that's a really big puzzle of information that pieces together. Great, well, thank you again for sharing. And with that, I'm gonna turn it over to Megan Howson to present for the cetacean resource. Megan and Jerad, hi there. You seem to be on mute, Megan. Oh, there we are. And I still can't hear you. Let me see if I can unmute you. Nope, you are self-muted.
There we go. Now is it letting me unmute?
Yep, we can hear you now.
Okay, perfect. All right. So I'm Megan Howson. I'm the marine mammal biologist and data scientist with GCOOS. Jerad King, our GIS manager and developer, is also going to be presenting with me today. And we're going to present the cetacean, or the GCOOS portion of the cetacean, so the compilation of environmental threat and animal data for cetacean population health analyses platform. It's a bit of a mouthful. And we're also working on this project with NOAA. From the GCOOS perspective, some of our project objectives and a little bit of background. So this project is funded through the Deepwater Horizon Open Ocean Trustee Implementation Group as part of the Restoration Plan 2, which includes looking at sea turtles, fish, marine mammals, so our portion, as well as benthic communities. And our goal was to create a platform that provided access to data and analytical products related to cetaceans and some of the stressors that affect them. When doing this, we really wanted to focus on providing open access data, as well as making this data easily searchable and easy to visualize. Some of this data is hosted in a multitude of different other places, but it's not necessarily easy to find it or easy to visualize it, which really provides a barrier to restoration managers, the public, as well as other researchers. And so our goal with this was to try to remove that barrier. Our partners at NOAA, AOML, are also working on a web application utilizing some of these data sets. So we needed to make sure that this data was easily accessible and to build a data pipeline to meet all of their needs. Some of the data categories that we are focused on, but not limited to, include population data. A lot of the data that we're looking at for population includes different federal data sets, some movement or animal tags, as well as species distribution models. And as we were going through this data, some of it is in GIS format, some of it was only in tabular format, and again, some of it was not very easily accessible. So we have gone through and done some data joins, some different transformations, so that not only can you access data from the authoritative source, but everything is also able to be accessed as a GIS layer or just visualized that way. So different users can go through the platform, see where these different marine mammal surveys have occurred, and decide if that is a data set that meets their needs. We're currently in the process of build one of this project, which is focusing on different stressor data sets. So all these different stressors have been identified by different subject matter experts as some of the key threats facing cetaceans that they are most interested in. So we are adding vessel traffic data sets, some anthropogenic noise data, fishing location and effort, as well as offshore wind lease sales. And then as we look ahead to the future and move into build 2 of the project, we're going to be focusing more on environmental data. And this really fits in well with GCOOS as a whole and things that we've done in the past. We have been very focused on collecting environmental data in the Gulf of Mexico. And this is a nice crossover between the two projects as we begin to pull this into our data repository. Going back to some of our focuses for this and trying to make the data very easily searchable. All the data is hosted in an Esri GIS hub. That was a format that worked very well for us. And we were able to make that data searchable in several different ways. So to meet different end users' ways of thinking, ways of approaching trying to identify different data sets. So they can either just search keywords, or if they know exactly what data set they're looking for, we do have a search function within the hub. And we have also grouped the data. So if someone knows that they are looking for a population data set, but they don't know what different ones exist, they're able to filter through and just look at population data or threat data or environmental data. We also have a category for ancillary data, so things like different boundaries such as exclusive economic zones, marine protected areas, fishery management areas, all of these different resources that may aid in somebody's project, but don't exactly fit specifically in a cetacean data set. We're also including that just to make everything as accessible and easy to use as possible. And users are also going to be able to explore data by collection. So one of the key data sets that we have in here are different GOMAP surveys. This is one of the major marine mammal surveys done by NOAA throughout the years. And so if someone knows that they're specifically looking for those data sets, they are able to do so just by searching for different collections or different projects, and all the data sets that fit within that project will be accessible that way. And then I'll pass it off to Jerad to talk a little bit more about building the hub and some of the more technical aspects.
All right, well, thank you, Megan. I'm Jerad, the GIS manager and developer for GCOOS. So I'd like to talk a little bit about Cetacean as a geographic information system and why it's more than just a hub page, how we leverage ArcGIS Online infrastructure and APIs to ensure there are multiple points of access for data sets to support a diverse user base across all skill levels. I'll also talk about some of the supporting projects and applications that we're developing during Build 2 and what the next steps for us are. So as Megan mentioned, Cetacean, its data, application, all the supporting services operate within the ArcGIS Online ecosystem. This is great because it allows you to integrate data from the Cetacean hub into your existing Esri cloud-based and local application workflows. In particular, this might be relevant for something like processing AIS data, where a single data set is multiple gigabytes for a single month. That might not be practical for a user to use cloud compute resources to perform that analysis, but we have a content group that enables you to access all the Cetacean Hub data locally in ArcGIS Pro. So in an instance here, we have the catalog pane and you're just in the ArcGIS Online portal and you have full access to what would be available on the hub. And that allows you in a few clicks to now have a species distribution model and AIS data. So more time for analysis and less time actually searching for data. And we'll talk a little bit more about some of those supporting applications on the next slide. So in thinking about where to source environmental data from, a glaring option for us was, well, we're GCUS. We fund a network of sensors that collect environmental data, but all that data is on AirDAP. So we thought it might be cool to develop a workflow to add AirDAP data near real time into ArcGIS Online. Thus, AirDAP to ArcGIS Online was born. And this adds the capability of near real-time AirDAP environmental data to our data repository. This is a Python package that you install into an ArcGIS Online notebook, and with a few clicks, you can add AirDAP data as is on the server to ArcGIS Online. What's also exciting about this is you can clone your own AirDAP service to ArcGIS Online. So perhaps if you have a deficit of ocean observing observations for your dashboard, you could use AirDAP to ArcGIS Online to get that data in GIS format easily. We also have the Cetacean Data Atlas, which is designed to just add another option for a user to add data. Since the data represents population, threat, and environmental, it's intended to be used in concert with each other. So it helps to see that data along a spatial domain, and that's the purpose of the Data Atlas. And if we could go to the next slide where we'll see an example of how simple it can be in AirDAP to ArcGIS Online. So here we're just selecting which server we want from the server presets, specifying a data set ID, and then we get a little bit of information about that data set on that AirDAP server. Click a couple buttons, and next thing you know, we're graphing AirDAP data on ArcGIS Online. So really excited about what this is going to do for the Cetacean project and the broader ocean observing community. Then on the next slide, we can see a prototype of the Cetacean Data Atlas.
Hey, Jerad, you've got about a minute left.
Got it. And what you can do with that and visualize data. So on the next slide, we have some of the next steps. We're going to continue to process and populate the hub with the threat data, continue development on AirDAP to ArcGIS Online and the Cetacean Data Atlas. Once that's complete, we will be adding the AirDAP environmental data to the hub. And because we want to make this as effective for users as possible, we're looking for feedback. So on the next slide, you'll find our contact information. If you're in the market for cetacean data and want to do a study, maybe try using our resource and see if what you're looking for is there. If not, reach out. And if you want to contribute to the project and say you have a survey that you would like to provide, reach out to Megan. Anything related to the GIS side of things or the AirDAP pipeline, reach out to me. Thank you all for listening.
Thank you, Jerad. Thank you, Megan. This is really exciting, and it's just neat to see all of the different things pulled into that one cetacean resource. That's great. I'm curious, as this continues to develop, what excites you most about the use of cetacean and how people might be able to use it? Or what's your favorite part of it?
I'm really excited about how we're able to join multiple different data repositories so that all cetacean data is in one place. NCEI has been a great resource. CMAPS is a great resource, but they have a lot of data just beyond cetacean data. And it's not always necessarily very searchable unless you know specifically what data set you're looking for. So this makes it really easy for somebody who knows they want to do something with cetaceans in the Gulf of Mexico, but not necessarily what different data sets are out there. It provides a really good starting point for those users.
Great. How about you, Jerad?
Just as a self-proclaimed GIS nerd, I'm excited by the workflows that we're developing and how the product impacts of cetacean will extend beyond the project and into the broader ocean observing community, as well as how we can use the infrastructure developed for cetacean in our future projects.
Wonderful. Thank you both. Really appreciate it. And thank you everybody for attending and for all of your questions. We do have some more questions that came in, and I'm really sorry we weren't able to get to everything. But as I mentioned in the chat box, please do know that we do have your questions in writing, and we'll be able to get those to the presenters as well afterwards. So just wanted to thank all of our presenters again. Paul, Chris, Don, Adam, Megan, and Jerad, thank you so much for sharing today. It was such a great representation of different things that are out there for us to use. And I wanted to mention real quick that our next webinar in the series will be on December 5th at the same time. And we will have a presentation from the Gulf of Mexico Integrated Ecosystem Assessment Group. So that should be a really neat section or session of different topics. So thank you all again. I appreciate you, and I hope everyone has a great day. Take care.